this computer. So we're gonna keep our rule, and I'm gonna ask you more interaction, meaning you will not just log on, but just actually participate in the class. All right. So, okay, content share. Okay, 3, 2, 1. So we talked about the basic introduction of the class, and we solved a couple of problems, and I think we are ended up on this point. Okay, some of you may mention what is the best job to do, and some of you give me a nice approach. And for the right answer for this is selecting the closest, selecting. So it could be multiple answers, but the basic one is always job first. So start working. Okay, start working as soon as their work is available. So accept all the jobs, then which does not overlap the others. Then what happened? If that is the case, like this one. So if the job started in here, then I'm taking this. Therefore, you are missing 5 jobs, but he or she only able to do 1 job, right? That is the case. Therefore, that approach is not good for your star. And find the shortest job first. Then, what if this case? I choose this one because it's the shortest job, but you actually could able to do 2 jobs, but you are only doing 1 job, right? Also, the first job to complete may be the right answer. Then, how to prove it? Proof is proof by the contradiction or proof by the proof by the contradiction is usually what we do. So proof other jobs may well have started before the first to complete, but all must at least partially overlap both X and the others. So thus we can select at most 1 from other groups. So first to complete X is so selecting any job, but X will be the opportunity to the next. Let's talk about this. So by the proof by contradiction is demonstrated incorrectness. So search for counterexample is the best way to disprove the correctness of a heuristic. And think about all small examples like we discussed these cases. Let's cover this. What if I choose the first the earliest closing job, earliest ending job first? So in this case, I'm going to choose this job because it ends here, then ends here. Oh, I'm able to pick 5. On next case, on this job, earliest job first, earliest ending job first. I'm choosing this job and this job, so I'm choosing 2. Can you give me a counterexample that the first job to complete is correct one? So can you prove that the first job to complete is wrong, meaning you are able to give me counterexamples? Can you? So let's talk about this. So the best way to your algorithm is wrong, meaning as I'm giving you a counterexample. Hey, if that is the case, how about this case? Okay, so my answer is the first job to complete. And if you think it is wrong, or you can give me a better approach, and you may give me an example to kill my approach. Anyone? So.
Professor?
Yep, go ahead.
Is that first job meaning like the earliest job that
No,
person can?
Ending job.
Sorry?
Earliest ending job. First job to complete. So you have a starting time and end time. So what I'm going to do is I'm going to sort all my job based on my end time. Then I'm going to sequentially choosing that job as long as that is not overlap with the others. Good. Okay, I'm gonna solve this one in program. All right, anyone else? Can you give me counter examples?
Professor, I think like it might be like wrong because during the maybe like this first job might be like really long, and during that time there might be like two different jobs or three different jobs.
Okay, can you take over the share screen and draw on your computer?
I don't know. I don't have like tools
No,
for
just
that.
a
Like,
pad or yeah, I'll try to understand. Okay, how
uh,
about this? You are saying, can you
there's
say
like
that
if
again?
you like draw like long line,
Long line.
yeah, maybe like you showed it before. Like there's like three different jobs during that time as well, but like
Like this.
yeah.
Then,
Yeah,
if I choose
yeah,
the earliest job complete, then I will choose. I'm gonna sort based on this value, and this value, and I'm gonna choose this guy and this guy,
yeah.
right?
Right.
Is everybody clear? So for everybody, so we are trying to say, oh, your algorithm wrong. If then, give me an example. That's a proof, right? So Ulbach will just try to give me one approach. Kind of try to give me one example. Is that what you mean, Ulbach?
Yes.
Okay, so in this case, I will choose the correct one, right? Anyone else?
Professor,
Ulbach? Yeah.
Professor, this is Kangtaek Kwon.
Okay.
Kangtaek Kwon, and I believe if you draw the one line that you drew up, if you reduce the line, maybe then your algorithm is wrong.
Okay. So you are saying this one, and this one, and this one. This is what you're saying.
Yes.
Okay. What I'm gonna choose. Okay. I'm gonna pick this guy first because it has a list job.
Yes.
Then this one automatically discluded,
Uh,
right? Then I will choose this guy.
okay.
Therefore, example is not kill my weight.
Okay.
Okay, good job. Okay, thank you. Anyone else?
Professor, what if
Hanson?
Hassan,
Yeah.
on that timeline, what if there is two more
Two
the-
more.
for the first row? What if there's two more movie things?
Two more. What do you mean? So I'm gonna first line.
Can you draw the
Okay, then.
and on the second row maybe shorter than the first row?
Like this.
Yeah, and maybe there are another like two more movie thing on the first row. Yeah, and the just one another row on the second row, another line on the second row. Yeah, yeah, and then if you pick the earliest one, you may pick the second row. Is that right?
Okay, so let me try what I'm gonna do. So I'm gonna sort based on ending time, right? So I'm gonna choose this guy. Then this is automatically discluded. Then I'm gonna choose this guy. This one automatically discluded. And I'm gonna choose this guy. So my answer is 3.
Okay.
And can you pick the 4 out of it? No.
Sorry, can you pick what?
The example is correct, or maybe you can do, you can take over the share screen, draw on your computer.
That's what I was going for, but I guess I was wrong.
Okay. All right, thank you. So Youngjae says no counterexample, yes. If you cannot find the counterexample, so then it is okay. I'm suspicious, but by now you are good. That's it. That's so far what the human being can choose. Then your algorithm is correct in the view of like this. Thank you. So there was no counterexample in this case. I think it is right answer. And this is how we teach in the class. So there is two methods. I can give you counterexample, or I can give you induction and recursion. Okay, so failure to find the counterexample to keep the algorithm does not mean it is obvious that algorithm is correct. Okay, right? So we talk about, oh, there's no counterexample, so you are correct. No. That's not obvious. So I want to prove it. Okay, so mathematical induction is very useful method for providing correctness of the recursive algorithm. So recursion and induction are the same basic idea, basis case, and general assumption and general cases. I'm assuming you learn all about this, right? So all this basic case, what's the sum of the I from 1 to n? Oh, I can prove it. So you learn in the basic mathematics, right? So by doing this, you can also do this. All right, so today, I'm gonna talk about the asymptotic notation. So I'm gonna upload this file. I tried this before the class, but my computer is not turning on properly. Just give me a second. All right, so today we're gonna talk about the asymptotic notation. So this is afternoon, so I want you warm up your brain. Let's talk about this. So not this one. So if you have a problem of the disability, please contact the 821, and there's a one-stop service. If you have some disability to talk about and consult, there is always a person who will help you. Okay. All right. So problem day. So let's think about for 5 minutes, and let's discuss about this. So problem is, the knapsack problem as follows. What's the knapsack problem? Your knapsack is like this. Knapsack, right? Okay. Maybe this is my knapsack, and I'm a thief. I can carry up to 22. Okay, but I cannot carry 23. So what's the best way to carry this in the view of algorithm? All right. So assume you are the thief, but you are the smart thief because you're thinking about the software and algorithm. Okay. So knapsack problem is as follows: given a set of integers and the given target number t, as much as you can carry, and the subset of s, which adds up to exactly to t, the target. So for example, s is a set of this value, and there is a subset which adds up to the 22, but not 23. So how can you make 22 out of it? I'm going to choose 1, 2, 9, 10. Then it will going to add up to 22. Okay. All right. This is knapsack problem. Find the counterexample to each of the following algorithm for the knapsack problem. That is, given an S, the set of the value, and T, such that subset is selected using the algorithm. Does not leave the knapsack completely full, even though such a solution exists. Okay, so your problem is, okay, I have a set of integers and my target number. How can you make 22 quickly and correctly? Everybody understand? Okay,
Yes.
so I'm a thief. I'm carrying a knapsack, and I see the jewelry with only the weight, only the volume. Okay, my job is carry to my target value. Then your algorithm should be running quickly, right? If you pick the 22, or if you pick the 23, you cannot carry. Then if you are 21, then you still have a one space. I want to make a 22, your target value. So how can you program? What's the algorithm? Everybody understand? Clear? So you are now thief, but you are smart thief. So how can you program your smart? What's the algorithm? Okay, let's think about for 3 minutes, then we're gonna discuss about your approach. Ready? Okay, let's solve the problem. Who wants to solve? Okay, I'm gonna pick Guy if you not volunteer. Woo-hyun?
Yes.
Okay, can you solve the problem? What's the strategy to be a nice date?
Actually, I don't quite get the problem.
So the solution could be, I'm gonna pick the bigger one first, then I'm gonna sequentially pick it,
Oh.
something like that.
Oh.
Okay, so let's talk as to Kwangmin.
Yes.
Yeah, can you solve the problem?
I thought that, like you said, I could put the largest to the smallest. So for example, as if we have to put 22, so we can put 10 first, and the rest of them we can sort them with the largest to smallest. Or we can also say from left to right in order.
Let's solve the first one first. Okay, why is my iPad? Okay, my set is 1, 2, 5, 9, 10. Goal is 22. So you have knapsack, and Kwangmin's algorithm is pick the largest. So what I do is I sort. So I sort the biggest one up, so largest to smallest, then 1, 2, 5, 9, 10. Our target is 22. What I'm gonna do, what he's gonna do is sort largest to first, 10, 9, 5 to 1, and pick one. Then adding up, okay, then 5 is adding up. Then it is not satisfied. What you gonna do?
Oh, we go for the second largest one from the list.
Second largest one?
Also, if we do 10, 9, and it adds up to 19, and after that, if we add up 5, it's not possible. So we can add 2 after that. Like second the largest from the list we haven't used. So like 2,
or
1.
dropping this, and you're gonna edit this.
Yes.
Right, then 21, and you're gonna do add up 2, then you'll achieve 22.
Yes.
That is your algorithm, right?
Yep.
Okay, let's go back to the point. What if the case is so what if this is my set, my target is still 22? Okay, so based on your algorithm, you're gonna pick 15, then you're not able to get 12, right? Because it exceeds. Then you're gonna add up 7.
That adds up to 22. Oh,
yeah. Add up to 6. Then it's 21. Then your 5 is not possible. 3 is not possible.
Oh.
Right? What you gonna do?
There may be a problem.
Yeah. How can you solve this problem?
Hmm.
2, 3, 4, 6. Clear the whiteboard.
maybe we have to reset the starting point from the second largest,
Yeah.
which is 12.
3, 5, 6, 12, 15. My target is T is 22. We are able to do 12 too.
Yeah, start with 12.
Yeah, start with 12.
So 8. Yes, it is possible. So your approach is, Kwangmin?
So we have to reset the starting point to 12 instead of 15.
Okay, so
So
you
it's gonna be
started
12.
from 15, then give up 12 and 6, that's 21. Then you are 5
No,
not possible. Right. So 3 and 2 not possible. You end up, right? Then you're gonna keep up this guy.
Yes. And
So you should
start
keep
with
up first, isn't it? Based on your algorithm. A or B.
He's
You should-
resetting like
You should
he's
give up
resetting
A.
the first number.
Hmm?
Like he's resetting the first when he chose like 15 first, it didn't work, and he's resetting the first number to 12
So
and not
we
12.
talk
And
about the algorithm, not about this specific problem. So if you set up the algorithm, it should work on every example, right?
So what if the algorithm can be like, if the first largest number doesn't work, we can move to a second largest number.
Okay, so your algorithm is, so you keep up A and B sequentially, and it turns out, if I picked up 15, it is not working. So you're gonna start to pick 12, then 6 and 5, which is 23. You already exceeded. What you gonna do?
So we gotta remove 5 and 3, 2.
3.
Wait. 하면은
Then
21 안 되네.
that's
21, then 2, not working. Then what you
Yeah.
gonna do?
remove 12 from the subset and start again.
Remove
12. Oh,
Professor, can we make the 22 at the first example? With the starting point at 15, we just give up the 6 and put 5 instead of it, and we choose 2 at the last.
yeah.
Okay, then because your brain says that, right? But how about in algorithm?
But so like at the first point, if we give up A instead of B, then maybe, so we just first chose 15, but 12 cannot be because it exceed and make it to 27. And we chose 6, but it won't make 22 because the last of the numbers are bigger than make it to be 22. So we give up the 6, then we choose 5, then it makes 20. And when it comes to 3, it becomes 23. So we also give up the 3, but if we choose 2, then it makes to 22.
Okay, good point. All right, so here's a strategy.
So instead of giving up the largest number first, but we give up the resting the follow up the largest number.
Okay, good approach. Sunjae, thank you. Kwangmin, do you understand?
Yes.
Okay, go back to the point. I know. So what's the strategy? We call the backtrack, the basic backtrack. So let's say I have 2, 3, 5, 6, 12, and 15. What I'm gonna do is I'm gonna draw a tree. Okay, under the root, there's all possibility, but I cannot do every cases. So below this is only possible when it is a smaller. Smaller than is 12 and 6, 5, 3, and 2. So in here, there is no more leaf, right? But this one, 21, but I could have 5, 3, 2, but none of them satisfy, right? Then we're going to build the whole tree. It won't be large. Under the 5, it will be 3 and 2.
인천 글로벌 캠퍼스 통합 방지 시대에서 안내 말씀드립니다. 제8호 태풍 바비가 우리나라를 타고 있어 태풍 피해 우려가 있습니다. 캠퍼스 거주자분들께서는 다음과 같은 사항을 주의하시어 피해가 없으시기를 바랍니다.
Seriously.
사무실 창문 및 복도 창문은 태풍에 날아갈 우려가 있으니 모두 시건해 주시기 바랍니다.
Okay. Close your window.
주변에 있다면 미리 제거하거나 방제실 및 캠퍼스 근무자에게 신고하여 주시기 바랍니다.
If there is a stop hanger on, then report to the IEC.
외부 활동을 자제하여 주시기 바랍니다.
Stay home.
감사합니다.
Thank you. All right.
May I have your
Okay,
attention,
again.
please? This is the Incheon Global Campus Emergency Office. As the typhoon BAVI is heading towards Korea, we need your cooperation to prevent damaging the campus. Please close all windows in the building and put away things that may blow away in the wind. If you find any issues that should be taken care of before the arrival of typhoon, please report to IGC Emergency Office. In addition, please minimize outdoor activities for your safety. Thank you. 인천 글로벌 캠퍼스 통합 방지 시대에서 안내 말씀드립니다. 제8호 태풍 바비가 우리나라를 타고 있어 태풍 피해 우려가 있습니다. 캠퍼스 거주자분들께서는 다음과 같은 사항을 주의하시어 피해가 없으시기를 바랍니다.
So can you hear my voice even with the advertisement?
Yes, we can hear.
Okay, I'm gonna keep drawing. So my smaller numbers are only append to the lower. So 3 and 2. So this is a legal movement, right? So I have a 1 legal movement, which I can make a 22. Then from here, you can do same level, 6, 5, 3, 2. From here, 5, 3, 2. And 3, 2, and 2. And 12, 18, and there's no legal movement. 17, 20, no legal movement.
In addition, please minimize outdoor activities for your safety. Thank you.
Okay, 12 and 5, 17, 20 and 22. Oh, here's a legal movement. And you can draw all the possible cases. Okay, possible cases, not that many. Then you can find, oh, there is a two method to fill it up these cases. Do you understand what I'm doing? Okay,
Yes.
so
Yes.
think about all the possible cases and pick the one. But we are not doing heuristic. Heuristic meaning you do every possible cases. Rather than this, I made a simple rule. The subtree should be smaller, right? Then by having a subtree, then the tree size is not that big. Okay, Youngja says, I think the difference between best case and worst case complexity of the algorithm will be significant. So, any comment about this? Everybody clear how to solve this? Okay, so can I move on? So we
Yes,
solved.
clear.
Yeah, go ahead.
Clear.
Okay, all right. So we just solved the knapsack problem. We just warmed up our brain. The solution is put the element S in the knapsack in the left to the right order if they fit it. So that we call the first fit algorithm. Is it gonna work? Nah. So put the elements S in the knapsack from smallest to largest. We call the best fit algorithm. Is it gonna work? Nah. So put the element S in the knapsack from largest to smallest. Is it gonna work? No. We should have some strategy in the algorithm. Right? We just did before. So in the 373, in the algorithm class, we're gonna assume the RAM model computation. RAM model computation is simplified all the computation. So algorithms are important and durable part of the computer science because they can be studied in the machine and language independent way. So we use a RAM model. Why do we need a RAM model? If we don't use a RAM model, so your algorithm should be different all languages. So let's say Python using plus is more expensive than minus. Then in the Java, let's say minus is much cheaper than multiply. So in the algorithm way, we assume that simple operations plus, minus, equal, if, and call just assumed as one step. Okay, and loops and subroutines called are not simple, and they depend on the size of data and the contents of the subroutines. Sort is not a single operation. And each memory access take one step. So we simplify to understand. Okay, so we take assumption of it. So we measure the runtime of the algorithm by counting the number of steps. This model is useful and accurate in the same sense that the flat earth model, which is useful. Okay. So who believed the flat earth? Who believed the flat earth? No, nobody? Since you are a scientist? Nobody believe it? Okay. But the earth is not flat. It's a round, right? Like a ball, right? But if you look at as a flat model, like a map, it's more intuitive to understand it. Oh, the US is on the right, and China is on my left, and everything looks flat. Easy and helpful for our understanding, but that is not actual. Okay, so in an algorithm, we are assume simplified cases for better understanding. Okay, so we're gonna talk about asymptotic notation. So first, we talk about worst case complexity. So 3 cases: best case, average case, worst case. Best case is, oh, that algorithm with the best subset, it took so small, right? That is best case. Worst case is, I'm giving you every cases and I'm only counting the worst cases. Average case is, I'm giving this set of cases, test cases, and that is average case. So what is most important for your computer, for your algorithm? Is the best case matter? Average important?
I think worst case.
Worst case important? Average? So why nobody says
I think
best
worst case.
So let's think about the best case first. Best case, if you write your report in the based on the best cases, then you sell it the product than what the other says. You claiming that, but it never happened that way, right? Because your case is so biased. Because your report says based on the best case. That is not scientific. Okay. So what's the average cases? Oh, I tested this range of the cases, this range of tested, and on average, it turns out that. What if your client took it and take a different set of the test? Then the average will change, right? But what if the worst case? Worst case meaning my code guarantee I tested every possible cases, and the worst case, it performed this way. So when you try to sell the product, you have to say, in the worst case, it takes this much. Best case is, depends on your size. It could be faster, much faster. Okay, so if you are a scientist, as we are software engineers, it always says the worst case, right? So best case, average case, complexity. So best case complexity of the algorithm is function defined by minimum number of steps taken on any instance of size n. So when the input size is small, it took so small. So I reported best case. That's not a scientist. And average case complexity comes with the function defined by the average number of steps taken any instances. So each of these complexity defines a numerical function, time versus size. So your input, what matters is what matters in your product work in this way. Over input size are bigger, your time. So when the size is big, your computation time will take longer, right? It's obvious. So A time, E time. Which time is more important? When the size is very small, time is small, of course. When the time size is big, time is big. So A and B, which point is more important? B?
B.
Yeah,
B.
of course B. Why? So let's say you are selling the car. Okay, my car works best in the clean and nothing happen road. What if you about to drive in the worst case in the high speed? It doesn't work properly. Rather than doing this, oh, my car tested on harsh condition and high speed condition, it works good. Meaning in the algorithm, oh, my search engine, okay, Google, let's say it's a Google works in my database. What happened if your database is real world? It's not working. So if you test it in here, hey, my Google wins the Google. You can't say that. You have to test in the big size. In the small size, you can beat it. But what matters is scale. Okay? So main approach in the algorithm is when the size is big, how long does it take in the worst case? Meaning, how can you guarantee? Okay, that's the matter. So our position and complexity analysis is, what would the reasoning be on the buying a lottery ticket? Is it based on the best cases, worst cases, average cases? How are you going to buy a lottery ticket? I'm buying at the best, right? I'm hoping, oh, I'm going to have $1 million and I'm going to buy something at the best, right? You're hoping that. So if you understand, if you're a mathematician, what's the worst case? Almost zero, right? Let's say you are pulling 5 numbers out of 46 lotto. What you expect? I'm gonna pick the 5 right one. And I'm gonna buy something. That is best case. What does the mathematician say? Oh, you're based on the lottery probability, you're probably you want to win is 0.000000001. Why you want to buy this? If you're a scientist, which one should you talking about? This case. Worst case. Okay. So generally speaking, we will use the worst case complexity as our preferred measure of algorithm efficiency. Okay. So maybe you can expect, and you're hoping that, but in an algorithm, in a mathematics, in a computer scientist, we always talk about worst case. And worst case analysis is generally easy to do and usually reflect the average case. Assume I'm asking for worst case analysis unless otherwise specified. Meaning that all the exam or whatever we do homework, I'm expecting worst case. Randomized algorithms are growing importance and require average case time analysis to show off their methods. So randomized algorithm is like, you don't do everything, but you shuffle a couple of those and you pick the best one. So we're going to talk about this more. So let's say this is your performance algorithm, and over file size, your time. Computation time. So exact analysis is very hard. Just look at this curve. How long does it take in here? How long does it take if the size is big? Okay, exact analysis. So what we're gonna do? We're gonna do, okay, I'm guaranteed this value, meaning it will not exceed this time. Okay, this one is, at least it will take more than this. Okay, that is asymptotic notation. So let's go over again. So we call the asymptotic notation, meaning I don't know exactly, but I'm thinking it is I can draw upper line and lower line. That's asymptotic. Why? Exact analysis is tough. Okay. All right. So best, worst, average case is difficult to deal with because the precise function details are very complicated. You cannot estimate these curves in detail. Okay. It is easier to talk about upper and lower bound of the function, meaning It won't take longer than this. It will take at least amount this time. Okay, so asymptotic notation, we call the big O, big omega, and the pi. Okay, so we're gonna more focus on big O. Why? Because we are more interested on the worst case. I want to know the what guarantee. Okay, so or as well as we can practically deal with the complexity functions. So this is, let's say this is function of f of n, and this function is g of n. This function well, h of n. Okay, so f of n and g of n, h of n, and function of n. Where should I put it? Big O and big omega. This notation goes to the boundary. So in this case, g of n is upper bound of f of n. Therefore, we are saying big O. And h of n is a lower bound of f of n. So the notation goes to boundary, lower bound. Clear? So you have to remember this. Very clear, very intuitive. So your notation mark goes to boundary. If your boundary is upper, we're saying it's big O. Your boundaries are lower, we're saying big omega. What happened to this pi? Pi means I can define upper and lower at the same time. Then I can do pi of. So we're going to talk about the pi of n more. So name of functions, name of bounding functions. So g of n is big of fn, means c times, which is constant, f of n is upper bound on g of n. What does that mean? Okay, g of n is big O of f of n, meaning, okay, big O has on f of n. They are the boundary. Okay, so f of n is upper bound of function g of n. Clear? So c is the constant. Then I'm going to talk about in the next section. So c is a 1, 2, 3, just constant. So if you have the function and you can make c of fn, then we can say, okay, f of n is upper bound of this g of n. Clear? So I'm going to talk about this more. So let's read through it. So g of n is omega of f of n, means f of n has notation, meaning f of n is boundary. F of n is a lower bound because omega, right? Lower bound on g of n. Clear? And g of n is pi of fn, means I can have upper bound and the lower bound at the same time. Okay, what is the upper bound and lower bound at the same time? So let's say this is my function, g of n. And if I can draw like this, okay, this is 1.2 x, y. This is y is 2x. If I can draw a linear line 2 times with a different constant, then if I can define upper bound and lower bound at the same time, then I can say, oh, this is pi of n. Pi of f of n is g of n. Clear? If I can set a 2 definition, 2 boundary with the c1 and c2. C is only the constant. Okay? So c, c1, and c2 are all constant and independent to n. Clear? Okay, move on. So big O, big omega, and pi. So let's focus on big O. So this definition implies a constant n0 beyond which they are satisfied. We do not care about small value. What does that mean? When the file size is small, we don't really care. But what we care is after the threshold, and the big numbers. Okay, so if you remember, so on here, so we don't really care about the small cases, but we care about the big numbers. I draw like this, and I win in here. Maybe I lost A and B. Which section is more important? B is more important, right? So we care about these sections more than this section. Meaning, smaller set, it doesn't really matter. I'm talking about the big set. Okay. So, G of n, f of n. What should we do? So, f of n is it correct? How about f of n omega G of n? I can write freely about this. Is it clear about this? So let me try again. So I'm seeing this function. This is how your program behaves. When this input size is big, you're working like this. Okay. Say your function, your program function is f of n. Then f of n, oh, g of n, c times of g of n is upper bound, right? Therefore, I can say, okay, upper bound of g of n. Clear? I can write the same thing in a different way. So your function is this one. No, C don't matter. So the this one repeat. So f of n is your function's behavior, and let's look at this one, f of n. F of n is your program's behavior, and you just define the g of n, which is your function's lower bound. How can you write them? So okay, what I'm gonna do first, f of n, g of n, then since I'm talking a lower bound, I can put omega, omega. What is your choice? Where should I put it? A or B? A. Right? Asymptotic notation goes to boundary. So omega g of n is a lower bound of your function. You can switch f and g, you can keep playing. But keep in mind, boundary takes the notation. Okay, so my goal is find the value, find the behavior after the threshold. When the small size, we don't care. We care about big size and meaningful size. Clear? So this one, your function's behavior is a g of f of n, and you are able to define this function and this function. This function is the same function, but with different C1 and C2, with different constants. Then, oh, then I can say, okay, f of n and g of n. Oh, because I have C1 and C2, I should say, then I should say A or B. Boundary takes it, therefore I should write this one. Let's talk about this. Is g of n is f of n's big O? G of n is f of n. And EC. What is the correct answer in ABC? What's the correct presentation of this function? A correct, B correct, C correct.
A,
Oh, Junghoon, ABC. You are correct. Why is it ABC? Let's think about this again. Nope. Nope. So what's the definition of this guy? Meaning I have upper bound and lower bound at the same time. Clear? Yes. Okay, Hyungtaek says it applies. So if you look at this guy and this guy, what is it? It is my upper bound, right? Okay, at the same time, if you look at this guy and this guy, meaning this is my lower bound. Clear? Therefore, f of n and g of n's relation is, I can say big O of g of n is f of n by looking at this two. Big O of g of n is f of n. This is my upper bound by looking at these two. Since I have a big omega, big O, same time I can say, oh, I'm a pi of gn. Clear? Any question? No? So simple? All right. Okay. So formal definition. So we understand the concept, right? So move on to the formal definition. So f of n is big O of gn if there are positive constant n0. We know what the n0 after the threshold, and c constant such that the right of n1, n0, the value of fn always lies on or below of c of g, which means I am a upper bound, right? F of n is omega of g of n if there are positive constant n0 and the c such that to the right of n0 after the threshold, the value of fn always lies on or above it, meaning lower bound. F of n is pi of gn if there exists positive constant n0, c1, and c2 such that the right of n0, the value of fn always lies between c1 and c2 of gn. Okay, both of them. Then it is my two bound, therefore it is pi. Clear? Okay, so if you have a question or if you're not clear, you can always raise your voice. Can I move on? Okay, so let's do example. So don't try to see. Let's think about it. So 3n squared minus 100n plus 6 is equal n squared. Is it true?
Yes.
How? So n squared
Yes.
look like this, and 3n squared is maybe steeper. And maybe a little detail with this one. Something like this. Is it true? How?
Yes.
Because we talk about c, constant. Then I can always c in here as a 3. Then
Yeah.
3n squared on my boundary, 3n squared minus 100n is always bigger on the left side. So I can say, okay, rather than doing this, okay, 3n squared will exceed this, right? If I can have some constant c, then I can say, oh, this is my upper bound. Not clear? Okay, let's do it again.
Yes.
So I want you to focus, because if you miss it, it will be hard to understand. Okay. So my question is this correct? Your function set. Okay. Let's try. So my first equation is y is 3x squared minus 100x plus. That is my function. And second function, y is x squared. Okay. But I can put constant. So if you look at this, blue line is always bigger than a red line. However you go. Do you understand what I try to say? Okay. So I can set up with the 2, which is not obvious. Blue line maybe take up by the red. So it's not obvious. But if I can find some constant, maybe 10, then it guarantees the blue line always, your line should be from here to here, right? X is your file size, Y is time intention. So if I can find one constant C, then I can say, oh, you can say it is big O n squared. Clear? We'll go back to the point. Okay. Coming in here. Oh, that is big O n squared. How about this one? N cubed. It's obvious, which is much bigger, right? Therefore, it is big O n cubed is upper bound of 3n squared minus 100n plus 6. Okay. And 3n squared and minus 100 plus 6 is not big O n. Go back to the point again. right? N is here, therefore it is definitely not a big O. It's not my upper bound at all. And what if it is N cubed? It is definitely my upper bound. Blue is definitely my upper bound. Okay. Even I put very small C. Oh, it's look lower, but we're talking about the big size. If you go to the maybe we have to go more. The blue will take up in the end. Yeah, blue will take up in the end, right? Meaning blue will be the upper bound. All right, this is how we do the big O notation. Go back to the point again. Okay, so big omega, same thing on the lower bound. Okay, so 3n squared minus 100n plus 6 is n squared. Because I can put smaller, then it is my lower bound. You want to prove it? So I can do, let me share this again. Blue is my lower bound, and it will be continuing. Even the file size are bigger and bigger. Okay. So again, okay, now we understand the concept of a big O and big omega. What is my upper bound? What is my lower bound? Okay, so big theta, same thing applies. And theta, big theta is basically big pi, big theta is basically, if it is big O and big omega at the same time, then I can say big theta. If not, if it is only, no. Okay. So I put a useful link for you to understanding math for computer scientists. Very nice PDF. You can quickly review the PDF and equation visualization. We just use it and online code Replit. You don't need to download the Python, but you can code in the replit.com. And how to visualize algorithm. It is very useful. You can click it. You can test all the algorithm there. Okay, you can also edit some algorithm. Okay, all right. So today I'm going to talk about the. I want to talk about the homework. Okay, so you are going to have a homework this week. Then how can you solve it? The starting point of homework is Anaconda. Anaconda download. Go to there. And download your Anaconda. It is free. Your individual edition. And you can download this. Okay. After downloading it, you install this. Then it will show up like this. It will look like this. Anaconda Navigator. In the Anaconda Navigator, what you're going to do is using Jupyter Notebook. Click. Then it will show you your computer. Then I just download my homework number 1 in my desktop. program practice, let's say program practice 1. You will see like this. Okay, then from here you're gonna solve. Let's try to solve the different problem 2. So problem 2 is what we solved. What we solved, a movie star manager. So a movie star wants to select the maximum number of starring roles such that no 2 jobs require in his presence at the same time. Okay, so input is 0, 1, 1, 2, 2, 3, 5, 10, meaning starting time, end time, starting time, end time, starting time, end time, starting time. What should be the output? Based on that, it should be 4 because there is no time to overlap. And 0, 1, 1, 2, 2, 3, 2, 10. What should you choose? You should choose this guy or this guy, this guy or that guy. Okay, so your job is from here, this is the code you'll given, and you're gonna write the answer in here. Okay, first you're gonna sort based on ending time and add to then append to new job list as long as not overlap. Okay, this is what you're gonna do. Then return the number of jobs you can do. Then at the end of the code, I made some test cases. How long does it take to compute the hard cases? Okay, then you save this file, save as your name. Okay, let's say it is Hasong CSE373 homework PP1, right? And go to the folder. Where are you? Then go to there. You can rename your file and submit to TA. Okay, that's what you're gonna do. So you are submitted by a classroom, Google Classroom, and I will make a slot for you. It will be intuitive to use it. And good news is we have TA for the class. So Team Kim is Taekyung Kim is our TA. So the best way to contact Taekyung is write the thread on the Google Classroom. Then he will reply, and he will collect your submission, and he's gonna score the your code, your algorithm. Okay. The algorithm, the philosophy or your score is not about I'm gonna give you 10. I'm not gonna give 9. I'm not gonna give you 9.5. I'm gonna give you 1 if you're satisfied. 1.5, maybe 2 if your algorithm is unique and superb solution, and it is not copied from me. If you copy from someone else or somewhere else, then it will be automatically 0 or minus value. Okay? Don't copy. Try to do something. I'm not giving you, okay, that was right, I'm giving you 10. No. You're gonna give, oh, you tried, then it up. Okay, I'm satisfied. Then you'll get a 1. If you do excellent job, then I will give you some extra credit, which is 1.1, 1.2, something like that. Okay, that is how you do homework. And even you are not able to solve completely, it is fine. Submit as you do, but late submission is late submission. Okay, if your submission is more than 2 days, we will not accept it. The 1 day, 1 minute late is 1 day late. Okay, so think about it. All right, so over the semester, you will going to have many homework. Then first one will be about 3 or 4. Then it won't take long, but it will take some time to think about it. Tease your brain first and write the answer. While you're teasing your brain, talk to your fellows, talk to your friend. Okay, make a good friendship. All right. So I think it is very intuitive to do a homework, make a good friendship, discuss about it, and write your own program. Don't copy from internet. Don't copy from someone else. Okay. The question is not hard. I'm not giving you hard questions, but I'm giving you very famous question you have to know. Okay, and it will definitely help you for your job in the end. All right, question?
I have one question. So for the homework, do we need to write our own sorting algorithms, or we can use the one from Python?
You are using Python algorithm. You don't need to write down sort. You don't need. You are just using the Python library. That is fine.
Okay.
But your job is write the algorithm. That's it. Therefore, that is simple. Clear? So I wrote the most of the outline. So your job is just fill out the blank section. Anything else? No? Good to go? Homework will be easy, but don't submit late. And we have a TAs for the homework, and he'll take care of the homework. All right? Any question? All right, so I assume you are expert on the Python. Okay. All right. Thank you, guys. And I will upload the video and the homework maybe today or tomorrow. All right. Thank you.
Thank you.
Thank you, Professor.